What? Okay. Well, it says it's live. I don't see it. Your channel. Oh, there we go. Okay. There we go. There we go. There we go. There we go. All right. 1 second before we get started. Drink some. Oh, there we go. Okay. Cafe. There we go. There we go. There we go. Ah. Kona coffee. Kona coffee. In my coffee. In my blood. In the cup. All right. Ready to dive back into AI? We're going on chapter 3. What is attention in language models? What can you tell us about words, right? What is one of the biggest problems with words? Probably between foreign languages and English, right? Coming to English, one of the hardest things that people say is hard to adjust to is different meanings for the same word, whether that word be the same spelling or the same phonetic pronunciation. These words can have different meanings and thus go down completely different paths, especially when you put those words into sentences. So a huge roadblock for language models is when a word can be used in two different contexts. When this problem is encountered, the model needs to use the context of the sentence in order to decipher which meaning of the word to use. So it has to look at every word in the sentence and then decipher, okay, how often does this word get used when bank means this? How often does this get used when bank means this? So if we're talking about a riverbank, the words water or mountains or I think my OBS just froze. I don't know what's going on. Oh, well, now we got to fix this. Huh. Well, like I can see it on the YouTube live. Like I can see the video is working, but my OBS is frozen. I can't even like access my screens. On the YouTube live, like I can see the video is working, but my OBS is frozen. I can't even like access my screens. I don't even know if this is going to record, to be honest. So let me quit and reopen. The fuck? Hmm. It's like frozen. I don't know how to fix this. All right, let's try to do this again. It's like frozen. I don't know how to fix this. All right, let's try to do this again. Hmm. I don't know how to close this, dude. Hmm. Okay. Hopefully this fixed it. It says it's still recording, even though I clicked quit. Should see my my camera pop up a little bit. There we go. There's me. There's the me with the FaceTime camera. It says it's still live. It's still recording. Okay. Let's get back into it. What is attention to language models? So you can see in this picture, there's on the left-hand side the word bank, and on the right-hand side also the word bank. And this is something that's very interesting about language, or even the English language in general, is that these words can have two separate meanings. And so a huge roadblock for language models is when a word can be used in two different contexts. So when this problem is encountered, the model needs to use the context of the sentence, so the other words in the sentence and the greater meaning of the sentence, in order to decipher which meaning of the word to use. This is precisely what self-attention models do. In the previous chapters, you learned, or we learned, about word and sentence embeddings and similarity between words and sentences. In short, why is this blurry? There we go. In short, a word embedding is a way to associate words with lists of numbers, which we know as vectors, in such a way that similar words are associated with numbers that are close by. So again, we learn that sentence and word embeddings have to do with the similarity between words and sentences and how we group them. And then we also learn that a word embedding is a way to associate a word with lists, and same thing with sentences. So similarity is a way to measure how similar those two words are by assigning large numbers to words or sentences that are similar and small numbers to those that are different. The higher the number, the higher that dot product or the similarity number is, the more similar those are. However, word embeddings have a huge Achilles heel. Okay, words that have more than one definition. That is where these LLMs, these AIs run into a huge issue. If a word embedding assigns a vector to, say, the word bank, it assigns the same vector to all the definitions of the word bank. So it doesn't matter that bank of finance is completely different than bank of river. In terms of vectors, they're the same. The word is the same. It's bank. So we have to figure out a way to have the AI understand the context that the word bank is being used, and also the meaning of the word being used, right? Because if we were to ask for a definition, it would have to return that also being context, but that would be a larger sentence problem. So this is where attention comes into play. Self-attention was introduced in the seminal paper, Attention is All You Need, written by several co-authors, including Cohere's co-founder Aidan Gomez. Attention is a very clear way to tell words apart when they are used in different contexts, which turns word embeddings into contextualized word embeddings. So again, you have the embeddings helping the AI and helping the machine learn how to store the word, where to go get the word from, and how to put words and sentences together. But now you have this problem with the AI where it can't decipher or distinguish between two of the same words. And so that is where this new learning or this new product comes into play called attention. So again, the problem that we're facing is we have one word with multiple meanings. And to better understand this, they give us two sentences: the bank of the river and money in the bank. And if we look at this visual right here, if I scroll, oh, you guys haven't been able to follow my screen, I just realized, because it wasn't scrolling. Let's do this. Boom. Boom. All right. Now we're scrolling. Again, so we had two sentences. We have two sentences: the bank of the river and money in the bank. Attention helps tell the context between these words. So if we look at this visualization, we can see the bank of the river. In this instance, bank comes before river. And in the second sentence, money in the bank comes after. And so not only do the sentences and the words mean different things, but context and attention also helps the AI pick up on the order of operations. Does it mean something when the word bank comes before context clues, after context clues? How long is the sentence? What are other words in the sentence? In versus of? You know, there's many different ways the AI can decipher based on embeddings of the words in the sentence. So how would a computer know that the word bank in the first sentence refers to a setting in nature, and in the second sentence to a financial setting? Well, let's ask a simpler question. How would a human know this? How would a human know which bank is being talked about? How did you figure out these two settings? How did you know which one is being talked about? The way you and I did it is probably looking at the neighboring words. What is in the first sentence? What is the word river associated with? Is it hinting at nature? It's hinting at a nature setting. In the second sentence, the word money is hinting at the word bank. It's in a bank. So in short, we need a way for this AI to use other words in this sentence to understand what context of the word bank we want to use. And this is where those word embeddings that we learned about come into play. As we learned in a previous chapter, word embeddings are a way to assign vectors, or these lists of numbers, to each word, okay? This person likes to imagine them geometrically. Imagine that the word bank, river, and money are all attached on a cork board. Isn't that like a little old, outdated? But a cork board is just, if you've ever seen It's Always Sunny, where Charlie draws all the connections with the strings and tacks, whatever. This corkboard contains all the existing words, and in such a way that two words that are similar, such as apple and pear, are close by. So apple and pear are going to be close by. And so now on the corkboard, where you have bank, river, and money, they're not exactly close by. However, what you do is you take the word bank and you move it slightly towards the word river, and you call this word bank 1, and you take the other copy and you call it bank 2, and you move it closer to money. And so now consider the following two modified sentences: the bank 1 of the river versus money in the bank 2. And this graph at the bottom here is going to show you a little bit what that looks like, where before, bank wouldn't know where to be situated between river and money. It might as well just be somewhere in the middle or completely not even relevant. But what this does is it creates those bank 1s and bank 2 embeddings of those words and moves them closer to their respective settings, okay? And so in these two sentences, the computer now knows a little more about the context of the word bank, as the word has been split into two distinct ones, both being the word bank. One whose definition is closer to river, and then on the other one's closer to money. And so in short, this is how the attention mechanism works. However, there may be many questions lingering in your head. For example, what do you mean by moving closer to another word? Why did you ignore the other words in the sentence? How did you know the words river and money were the ones dictating the context instead of the word the, in, and, of? And as computers only handle numbers, how do we attach numbers to all of these methods? Moving words on the corkboard. So this is how we're taking that word bank and we're moving it close to river, and the other one we're moving it close to money. Okay? What we mean by moving a word closer to another one is try imagining two words. Okay? Try imagine two words And for example, let's say that I want to move the word bank 10% closer to the word river. I now think of the word bank 1 as being 0.9 bank plus 0.1 river. That is, bank 1 is 90% bank and 10% river. Also, let's say that bank 2 is 80% bank and 20% money. So these modifications, bank 1 would be 0.9 times bank plus 0.1 times river. And bank 2 is 0.8 of bank plus 0.2 of money. And then how did we come up with these numbers? So that comes later, and the answer is similarity that we've learned before, and we can see how similar these are based on the embeddings. But for now, you may be wondering, what do we mean by 0.9 times bank and 0.1 times river? Well, in the embeddings chapter, we learned that a word embedding consists of assigning a vector of numbers to each word. Remember, a vector is this list of numbers compiled of different attributes that this word has and storing that in a vector. The cohere embedding associates each word with a vector length of 4096. So remember, there are 4096 numbers per word in this vector. And for simplicity, let's imagine an embedding that associates a vector of two numbers to each word in our example, and that the following are true. So river would be 0 and 5, money would be 8 and 0, bank would be 6 and 6. And just keep in mind that if you're using cohere, these embeddings are going to go out 4,000 more numbers. In our example, where river is 0 and 5, these two numbers can be interpreted as coordinates on a plane. Okay, if we recall back to lessons 1 and 2, we can draw a graph and plot them and see how close and far they are. Use that cosine efficient to see the similarity between the words or the sentences. And so these two numbers can be interpreted as coordinates, where the first number is the horizontal coordinate, and the second one is the vertical coordinate, as we said, where they can be plotted on this graph. Like below, essentially. And in order to calculate the embeddings of bank 1 and bank 2, we simply do the math that we just talked about, 0.9 times bank plus 0.1 times river. And what that looks like is it's 0.9 times 6 comma 6, because if we go back up for a second, we know that bank is 6 and 6. So 0.9, if bank 1 is 0.9 or 90% bank, it would be 0.9 times 6 comma 6 plus 0.1 times 0 comma 5, and we do that out, we'll do that math out, and we get 5.4 comma 5.9. And for those that are viewing, we can look at this as, okay, so 0.9 times 6, 0.9 times 6 plus 0.1 times 0, 0.1 times 5. And what we get are these other vectors where it's 5.4 comma 5.4 plus 0 comma 0.5. And so we add the same situation, the same happenstance in these vectors to one another. So 5.4 for bank 1, the first column, 5.4, plus 0 is going to give us 5.4. And then for the second column, 5.4 plus 0.5 is going to give us 5.9. And when we look at that down here, we can see that bank 1 is plotted in that range. As you can see, bank 1 is closer to river and bank 2 is closer to money. And so as a matter of fact, bank 1 is on the line between bank and river 10% along the way. Similarly, bank 2 is on the line between bank and money 20% along the way. Thus, the attention mechanism managed to split the word bank into words, two words, both bank 1 and bank 2, and use each one in the corresponding sentence. But you might still be having questions. And one of those questions is how to decide which words determine the context. Okay? In other words, why did I pick the words river and money instead of the, of, and in order to determine the context of the word bank? Well, obviously the answer is because I'm human and I know the language, but that's not going to be a good enough answer, and nor does this article think that's a good enough answer. But what can the computer do? It can rely on two mechanisms. One of them is a metric such as similarity, which we learned in the previous chapter. And the second one is a multi-head attention, which we'll talk about at the end of the chapter. So let's first discuss the similarity mechanism, which we've learned, which is the computer is going to consider all the words in the sentence as context, including irrelevant words such as the, of, and in. And then it's going to consider them in a certain amount. And that amount is precisely the similarity between the word and bank. And so we trust that in a good embedding, right? Assigning all of these vectors to in, of, the, these filler words. We also trust that the similarity between bank and the words such as the, is, of, is going to be 0, as they're unrelated. So if our embeddings are correct, we can also see that these similarities are going to be 0. Therefore, the model will know to ignore these words and focus on those that may have a higher similarity with the word bank. So if we go back to human language, we just think about how these consonants, or I don't know, I'm not a linguist, I don't remember what these filler words are called, but the, of, in, while they are a part of sentences, they're not actually describing the objects or the nouns in the sentence. They're not even a verb, right? They're filler words to help construct the sentence, and so that is where these embeddings come into play. They're showing that, okay, while these words are a part of the sentence and they're meaningful to the sentence, they don't actually have any similarity to the meat of the sentence, and that is where this attention comes in as well. And so here they add some numbers to that list, and we can see below that the and the are identical. They are very similar, but the is not related to bank, of, or river. And we can see here, based on our calculations above, remember where we had said that river and bank were very close. They were 0.1. So this bank 1 was 0.1 times river. We can see that bank is 0.1 times river in this context. And again, for money in the bank, it's going to be 0.25. Again, we did 0.2. This similarity makes sense in the following ways. The similarity between each word and itself is 1, as we can see that is correct. The is correlating to the. The similarity between any irrelevant word, the, of, etc., and any other word is 0, as we saw. The similarity between bank and river is 0.11, and the similarity between bank and money is 0.25, again, things that we've covered. Why is the similarity between bank and money higher than the similarity between bank and river? We can imagine that bank gets used more often in the same context as money than as river, and that explains the difference. Again, recall, a lot of these large language models that we will encounter, Llama or Gemini or ChatGPT, they are trained off of the open web, right? Grok might even be trained off of Twitter, of what's going on in Twitter, but we can almost use our context clues to decipher what people may be talking about in real world time, and we could probably guess that the word bank is associated with money or used in the context of money way more frequently than people are using the word bank to describe a river. I can't remember the last time I've ever even talked about a riverbank or used the word bank to describe the sides of a river. And so to simplify our calculations, when doing the comparisons, we simplify the model quite a bit. And although they're not exact, right, that bank and money are not exactly similar, and they're not always going to be exactly 0 when we compare the to the or of to however, we can see that money and bank are more highly correlated than the others. And so moving forward, if we're going to move on to the next step, we're going to use the similarities to transform each of the words of the sentence. And so we'll call all these new words the one, bank one, of one, river one for the first sentence, and money two, etc. for the second sentence. We'll be doing some math, but it won't be very different from the one that we did before. And so we'll take a look at the sentences, the bank of the river and the word the. The similarities with the other words are as follows. Similarities with the only one that is similar to the is the itself. Therefore, we turn the word the into the word the one, which corresponds to the sum of 1 times the plus 0 times bank, etc. And this is equal to the word the. That means the word the doesn't change and it's equal to the 1. So again, this is how it's trying to understand what's going on. And if we follow the same procedure for the word bank and see what we get, the similarities of the word bank with the other words of the sentence, the bank of the river, are the following: the 0, bank 1, of 0, river 0.11. Therefore, the word bank turns into the word bank 1, given by the equation 1 underscore bank plus 0.11 underscore river. We're almost done. We want the coefficients of the word to add to 1 so we can divide everything by their sum, which is 1.11, right? 1 for bank and 0.11 for river. And when we do that, we get the word bank and it gets transformed into the word 0.9 bank plus 0.1 river, because remember, bank 1, I'm sorry, was 0.9 bank plus 0.1 river. So let's do one more for consistency. The word money in the second sentence turns into money 2, given by the equation 1 times money plus 0.25 times bank. Again, if we recall, we are using money 2 to describe the second sentence, and money 2 in that context was 1 times money, because money is similar to money in a 1-to-1, and money is similar to bank by 0.25. So out of all the words in that sentence, the only words with the similarity values is money and bank. And when we normalize, we divide everything by 1.25, because 1 money plus 0.25 bank, to get the equation 0.8 money plus 0.2 bank. And all of these equations are summarized in the table. And this is the table. So this is the way we obtain the modified words that we use in the attention mechanism above. The modified sentences then become the following. The bank being 0.9 bank plus 0.1 river. The bank of the river being 0.1 bank plus 0.9 river. And that is the flip for the money in the bank. Money being 0.8 money plus 0.2 bank, in the bank being 0.2 money plus 0.8 bank. Is there more to attention? So what we learn in this chapter is simple self-attention. However, we can do much better than that. There is a method called multi-head attention, in which one doesn't only consider one embedding, but several different ones. And these are all obtained from the original by transforming it in different ways. And multi-head attention has been very successful at the task of adding context to text. And if we'd like to learn about more, we can check out these following 2 videos, which we will not be doing. But in all, we learned what attention is doing. And attention is a very useful method that helps words give words context coming from the sentence where they belong. And in this way, the model has less chance of getting confused by words taken out of context. So I want to scroll back up real quick before we finish, and I want to show what we went through, just so the context is still there. The original sentence that we were given was the bank of the river. Okay, bank of the river. Bank is not similar to the, of, or the. It is bank and river. The word bank is 0.9 bank. Okay, what does 0.9 bank mean? Excuse me. What we can see, and what we'll read again, is we want the coefficients of the word. So the numbers in front of the word, 0.9 and 0.1, we want them to add up to 1. They must. There's only one word. And so we divide everything. Where's my phone so I can show you? We divide everything by the sum of all the similarities in the sentence. And so for that sentence, the only thing that we got back, right? 0 for the, 1 for bank, 0 for of, and the's in there twice, and river 0.11. So if we do 1 divided by 1.11, we get 0.9. That is where that 0.9 came from. Likewise, if we do 0.11 divided by 1.11, we also get 0.09, rounding up to 1, or 0.1, I'm sorry. And so that 0.9 bank plus 0.1 river, that is how we get that association with the word bank for that sentence. So again, very high level, what attention is doing is it's looking at the embeddings, it's looking at the similarities between the words, and then it's saying for words that have 2 meanings, double entendre, whatever you want to call it, for words that have 2 meanings, it has to make a duplicate of that word for how, or triplets, however many instances of that word exist. Find out the context clues it's given for the words and the sentences, and then paste a copy of that word close to the area that it's used in. In the left case, it would be water, river, lakes, banks in that context. Whereas for the money context, it would create that money too and put it closer to bank, money, cash, all of that. That way, when someone types in the word bank or the AI is trying to recall something about the word bank, it is going to bring it back in the right context. Where so the money context would create that money to and put it. I need to like lower my volume. All right, anyway. It is going to bring it back in the right context. I think that is it for today, guys. Happy Friday. Thanks for joining. If you joined, I know it's just me with my 2 views, but we're growing. We're getting there day by day. Make sure you check out a Pear podcast. Very similar to these, but better voice, probably more so than listening to me. You don't get that hands-on where we go through the article itself, but they do a very good explanation. So go check out the first episode. These will be coming out weekly. Whereas my streams are 3 times a week. So you will get ahead of those podcasts, but they are short. They provide you a refresher. So best case scenario, I highly recommend if you really want to learn AI is go through these articles, go through these chapters, look at the examples, get a good understanding for the examples, and then listen to the podcast as reinforcement learning because they're a lot shorter, they're more concise, and they are a little bit, I don't want to say dumbed down, but they do a very good job explaining this matter in a high level context, as if 2 people were describing it in conversation. All right, well that is it. Thanks for joining. Deuces.